Okay, so now that we have our understanding of imaginary radicals, we are going to use that in order to solve equations with the quadratic formula that do not have real answers or basically have imaginary answers. So remember, our quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to be using that to solve our next three problems. Again, starting off, I always like to write it down, but obviously you don't have to. I like to go ahead and write down that a is 9, b is negative 4, and c is 2. That just helps me because sometimes I make really silly mistakes and put the wrong number into the wrong spot. So if I have them listed out, it just helps me make sure I put everything in the right spot. So let's start off. We've got x equals, we've got negative b. So remember, our b is negative in itself, and then we're sticking it into a negative, so that's actually going to make it a positive, plus or minus the square root of negative 4 squared minus 4 times 9 times 2 all over 2 times 9. So now we're just working with it and simplifying it down as much as possible. So we've got 4 plus or minus the square root. Remember, when you square negative 4, it is going to be a positive 16. And then when we do 4 times 9 times 2, that is going to give us 72 over 18. Okay, I'm going to bring this up over here so I have some more room to work. And we're going to have 4 plus or minus the square root. When we do 16 minus 72, that is going to give us a negative 56. Divide it by 18. And now is where we're going to use what we just talked about. We're going to simplify down 56, or negative 56. So this is 8 times 7. 8 is 4 times 2, and 4 is 2 times 2. So we do have a pair of 2's. That pair is going to come out here in front, as well as that negative as the form of an I. So we're going to have 4 plus or minus 2i square roots, and since we have both the 7 and the 2 left under, that's going to give us 14 over 18. And then I want you to look at the problem and notice, if I look at the numbers on the outside, in this case we've got the 4 and the 18 and the 2 and the 18, notice that they all are divisible by 2. So we want to go ahead and divide out a 2 for each one of these numbers. And that's going to give us our final answer. X is equal to 2 plus or minus I square roots of 14 divided by 9. Okay, and these guys, when we have these imaginary, their answers are going to look really funny because they're going to have those I's in them, so kind of be prepared for that. Alright, so let's look at our second example here. We've got 6m squared plus 3m plus 2. Again, we're still using our quadratic formula, so I'm going to start off by picking out my a, b, and c. So we've got 6, 3, and 2. So I'm going to start off, we got m equals, and the only reason I'm using the letter m here instead of x is because m is the letter that's in my quadratic formula. So we're going to go with that. And we got negative 3 plus or minus the square root. We've got b squared, so that's going to be 3 squared minus 4 times 6 times 2 all over 2 times 6. Alright, so keep going here. So we've got negative 3 plus or minus the square root of 9 minus, and then we're doing 4 times 6 times 2. That's going to give us 48 over 12. Again, simplifying down on the inside there. So this is going to be negative 3 plus or minus the square root of negative 39 over 12. Now, let's look at that negative 39. I can't actually break him down. He is 3 times 13. However, you'll notice there's no pair in 3 and 13, so we can't take out a pair. However, because this is negative, we still need to bring out that I and stick it directly in front of our variable. Our radical. So this is going to be m equals -3 plus or minus I square roots of 39 all divided by 12. And this would be our final answer for this problem. Okay, so we've got one more example to do together and then a couple problems for you to try. So let's look at our last example. We've got 12v squared minus 6v plus 10. So again, starting off by picking out the A, B, and C. So our A is 12, B is -6, and our C is going to be 10. So plug in those values into our quadratic formula. So V equals a -6, that's going to give us a positive, plus or minus the square root of -6 squared minus 4 times 12 times 10 all over 2 times 12. Now we're going to keep going, just simplifying that down as much as possible. So we've got 6 plus or minus the square root of 36 minus 480, that we got that from 4 times 12 times 10 over 24. All right, keep on going. So we've got 6 plus or minus the square root, and 360 minus 480 is going to be a -444 over 24. Again, we want to see if we can reduce that. So we're going to break this apart. I'm going to go with 4 and 111. That seems to be the easiest thing to break it apart, but remember, you can start with anything that divides evenly into 444. This is going to be 2 times 2. 111 is actually divisible by 3. It's actually 3 and 37. 37 happens to be a prime number, so we are done right there. We do happen to have a pair of 2's. We also have our I, our imaginary number, that's going to come out. So this is going to be 6 plus or minus 2I square roots. And remember, we're going to bring these two guys back together, put them under here, so that's 111 over 24. And then just one more thing, if we notice, look at all our numbers in front. Here we've got 6, 24, and 2, and they are all divisible by 2. So we want to go ahead and divide out a 2 out of each one of these numbers. So that's going to give us 3 plus or minus I square roots of 111 divided by 12, and that is going to be what our V is going to equal to right there.